only took a fraction of a second to launch that missile, but many hundreds of man-hours went ahead of that critical moment. To understand this fully, let's go back to the delivery of a missile at the Air Force Missile Test Center. But just what is a test center? As you know, the Air Research and Development Command, one of the major commands of the Air Force, is assigned the mission of attaining and maintaining qualitative superiority of air weapon systems for the U.S. Air Force. To achieve this goal, ARDC has 10 research, development, and test centers. In this team, AFMTC has the primary mission of evaluating test data obtained from missile test flights, not only for the Air Force, but for the other military services. Now let's get a clear picture of what makes up the center. First, Patrick Air Force Base, housing the command and staff functions. Then, Cape Canaveral Auxiliary Air Force Base, forming the jumping-off place for the Florida Missile Test Range, the world's largest outdoor laboratory. The range stretches from Cape Canaveral through the Bahamas, Caicos Islands, Puerto Rico, and in the future will extend to Ascension Island, a distance of approximately 5,000 miles. These downrange islands pose some special problems of their own. Supplies, for example. All perishables and personnel must be flown in from the mainland. Heavy equipment and low-priority shipments go by landing ship. Each of these stations on Lend-Lease from Great Britain is a miniature version of Cape Canaveral, with its own central control building, containing all the necessary equipment to track the flight of a missile and to take over safety and guidance control of it. Each station requires a crew of approximately 120 technicians. As soon as a missile is received, coordinating agencies at Patrick swing into action. Everything connected with the forthcoming test must be planned with pinpoint accuracy. The Bible for all this coordinated activity is the Operations Directive. This document spells out in minute detail just what every agency of the center will do to support the tests of this missile. The Director of Tests, through his project officer, is the official contact with the missile contractor and is responsible for technical test direction. The range facilities, instrumentation, and so forth, are the province of the Directorate of Range Development. For example, if the missile contractor had required certain peculiar instrumentation, it would have been up to range development to evaluate the need and fill it. The responsibility for actually operating and maintaining all this complex equipment rests with the Pan American RCA Group, which performs this function under contract to the Air Force. Everybody concerned knows his part in the scheme of things, so there's no last-minute discovery and consequent improvisation. Well, here is our star, our prima donna. Not looking her best at the moment, but this is the rehearsal period. This is when the hard work is done. All leading up to our version of opening night curtain, the launch. The analogy with an actress is not too far-fetched either. These creatures are incredibly complicated, but temperamental and dangerous. The approximately 30 miles of wire threading through her 74 feet of length hardly makes for simplicity. The 15 ground control switches and their attendant 300 relays can misbehave in the most annoying manner. So you can see why we call these creatures she. These temperamental qualities are why the watchword with any missile is test, test, and retest. The missile, just like an aircraft, must have an autopilot system. This is tested with the flight control test cart. We must also provide a means by which we can know exactly what is happening in the missile during flight. This is known as telemetry. By this means, we make the missile transmit automatically 140 different pieces of information, up to 600 if necessary, and we must be able to control or fly the missile from the ground. The command guidance system. Here's the command, and here's the result. Among the many exhaustive tests are the various engine tests. By use of such additions as this bell mouth, actual flight conditions can be simulated. Performance items, such as thrust, are checked in this control room. Temperatures, RPM and so forth are observed. A checkout of the radio-controlled throttle settings performed. These are, of course, only a fraction of the complete checklist. Determination of the center of gravity of a missile is so important that it must be accurate to 1/100th of an inch. It is checked in 2 nose down and 2 nose up positions. This is one of the last operations performed before the missile is moved to the launching pad. Since this means that actual launch is only 4.5 days away, other parallel activities are taking place. All aerodynamic missiles have one thing in common. They cannot launch themselves. They must be assisted by a good strong kick in the tail, supplied by rocket bottles or boosters. Since these things are just as tricky as the missile, they must be conditioned for a number of hours at moderate temperature. At Central Control, support activities are being alerted. All the highly complex organization of the Cape is being readied for action. Personnel to man the control operations room are selected and briefed. Orders go out to security police, who will patrol the pad area and set up roadblocks. Firemen, who have a heavy responsibility in this highly inflammable business. Even the snack bar must be notified to open at 3 in the morning. A man can't be expected to launch a missile without even a cup of coffee. At the pad, they're moving right along. Fuel is being put in under pressure, enough to drive an automobile 1.5 times around the world. It all goes in a little over 12 minutes. And here are our temperamental friends again, the boosters, now in position and being lined up with pinpoint accuracy. And don't think they're going to be allowed to sit here in the heat. Oh, no. This one on the other side has already been enclosed in a shroud, and cool air will be pumped in from a portable air conditioner. All over the Cape, equipment is being gone over. Film magazines are being loaded. Cameras are being adjusted. Radar is being checked. Radar plotting charts are being prepared for already the flight path of the missile has been determined. At Patrick, the weather officer is getting out a preliminary forecast, for good weather is vitally important to obtaining adequate photographic data. It is now F-Day, 7 hours before launch, and the countdown is in operation. A countdown, incidentally, is more than just a voice counting. It is a detailed blueprint for every activity that takes place in the 7 hours preceding the launch. Broken down into mechanical, electrical, autopilot, radio control, instrumentation, telemetry, and operations, it specifies what each man must do at any given moment. The operations must be performed in the order specified. Naturally, every key man connected with the operation has a copy. And not only on the pad, but in the blockhouse. Located as close as it is to the pad, this must be a heavily fortified structure. Actually, the personnel inside are below ground level. Those things that look like windows are periscopes. The blockhouse is the forward command post. Headed by the launch director, here is located the crew which is actually responsible for the missile in flight.
T-minus 270 minutes.
The engine operator. The communications man. Flight test engineer. Radio command control monitor. Radar plotting board operator, the eyes of the blockhouse when the missile is in flight.
T-minus 200 minutes and counting.
You are now in the operations room at Central Control. As the blockhouse is the forward command post, so this room is the nerve center of the whole range.
Okay, fine.
And the focal point of this vast web is the superintendent of range operations. He, like all other key men, works from the countdown you saw at the pad and in the blockhouse. Flanking him is his instrumentation supervisor. He is in direct communication with all instrumentation concerned with the shoot. Another vital function feeds into this room, interference control. Since radio carries all command signals to the missile and all information from it, it is essential that the frequencies used must be clear of interference. They are constantly monitored at various points, here at the Radiations Measurement Building, in a portable van in the pad area, and in a specially equipped C-131 flying thousands of feet over our heads. Back on the ground, other instrumentation components are checking in. Cameras are set up, both fixed and tracking. No easy job, this. Our girlfriend takes off in a hurry. Scattered around in strategic locations, some manned, some unmanned in the danger spots, we have no less than 38 cameras for adequate data acquisition. Not only the Cape, but the designated impact area must be covered too. Believe it or not, that's one camera. It can photograph a baseball at 5 miles. It acquires its target by radar. Then the operator takes over manually, but radar continues to work for him by changing focus.
T-minus 100.
Only an hour and 40 minutes now. We should be getting range surveillance reports. This is the primary concern of the flight safety officer. High above us, airborne radar, an early warning type in a C-131, is watching the whole surface of the range. Transmitted to radar scopes in the operations room, what it picks up is plotted on the range surveillance plotting board. Yes, those are ships, and it looks as if they will move into our impact area. However, they may be out of it by the time we're ready to shoot. But if they're not, the flight safety officer will advise the launch director that the range is foul. Backing up the early warning system is the search radar, the CPS-5. It is concerned primarily with the immediate area surrounding the Cape, and its findings are also plotted on the big plotting board below. Also on the roof of Central Control are Mod 2 radar antennae, those dish-shaped things which will track the missile in flight. Following a beacon signal sent automatically from the missile, the observations from these and others placed around the area are plotted in the operations room below. Already plotted here are the flight path of the missile and the impact and destruct lines. During the flight safety officer, by watching the moving pens, will know exactly where the missile is.
On my mark, it will be T-minus 70.
Okay, fine. Thank you.
Mark.
At this time, the air must be cleared of commercial traffic. The Miami Air Traffic Control is notified, and all aircraft diverted to an inland course. The superintendent of range operations receives a final weather report from the downrange stations over the submarine cable line. Weather good, scattered light stratus at 18,000.
Roger. Okay, fine. Bye. T-minus 65. Go ahead.
That's fine. But wait a minute.
Okay, we'll hold it.
They've run into a little trouble at the pad.
We are holding at T-minus 65. This hold is expected to last 30 minutes.
The constant testing and checking have pinpointed this potentiometer as malfunctioning. But this $15 item could cause serious trouble. Well, won't take long to replace it. But the sequence has been interrupted, and we shall have to pick up where we stopped. At least the tension is relaxed for a moment. No one likes holes, but they do give you a breathing spell. No matter how long you've been at it, this missile business is still a tense, exciting thing.
Well, here we go. Yeah. Go ahead. Roger, we'll pick it up in 1 minute. Stand by to pick up the count in 1 minute.
The new potentiometer checks out okay, so we can proceed.
T-minus 65 and counting.
At Patrick, the aircraft radio control pilot is checking the command system in the F-89 aircraft which will accompany the missile and form an emergency control station. Once he's in the air, it'll be too late to rectify any malfunction. So, in line with all other operations, the watchword is check ahead of time, and then recheck.
T-minus 55.
All personnel, clear pad for igniter installation.
Go ahead.
This might be a good time to check at Central Control and see if those ships are going to give us any trouble. All clear except that one. He's right in the area. But at the speed he's making, he'll be gone by the time we're ready. For the past few minutes, every instrumentation site has been checking in a ready report with the supervisor. Cameras and radar are already in. Here comes Central Timing, verifying that he is generating the timing pulse that governs everything on the range. A vital function, for without a common time, our data would be useless. Telemetry receiving building. Here is received all the information sent from the missile. Through this highly complex equipment, certain vital items may be selected for the real-time display panel at Central Control and the blockhouse. All items are recorded on magnetic tape for later data evaluation. While over here on the other side, all telemetered information is recorded on these pen recorders. These are started at T-minus 180 minutes, so as to record all telemetry test procedures as well as flight data.
T-minus 35.
The instrumentation supervisor looks worried. Wonder who he's talking to.
Go ahead.
Uh-oh, surveillance radar. Maybe he's picked up something.
Red 1, this is Red 3.
Hey, Fred, we got a boat in the 5-mile area. The range will be foul.
Okay, thank you, John. We are holding at T-minus 35.
Get a crash boat in there and get him out. Let me know when it's all clear, will you? Okay, thank you.
Well, this won't take long. One of the patrolling crash boats is not far away. There he is. Sure, it's a prohibited area. That only makes it more attractive to some people. One thing, he's not too far into the danger zone. Won't take long to get him out. By the time we get back, they'll probably have picked up the count.
T-minus 15.
We're getting very close now. At this moment, you're in the tunnel under the blockhouse, and the chief electrician is arming the boosters. Note those red plugs he takes out. You'll see them again. In the blockhouse above, the launch director is waiting a report from the tunnel. He gets it. Start the Ploost. In a few moments, this auxiliary air starter will in turn start the missile engine. There are the red plugs again. Nothing to be done until they've been handed to the launch director. Then he, the missile inspector, and the project officer must sign the release. Then, and only then, will the electrician hand over the key to the automatic sequencer, which will actually fire the missile. Over at Patrick, the F-89 chase aircraft is taking off. As soon as it's airborne, the pilot must check in with the ground control pilot in the blockhouse. At Central Control, the downrange stations are reporting in over the submarine cable telephone.
Attention all downrange stations. Attention all downrange stations. Report your readiness and sequence. Go ahead.
Station 3, ready for launch.
Roger 3.
T-minus 6 minutes. Start missile engine. Close safety circuit breaker and hold fire switch. Fire trucks off the pad. Take launch position. T-minus 4 minutes. Transfer from ground to missile power. T-minus 2 minutes. Shut off Ploost. Eject air umbilical.
Range clear. Okay to launch.
Sequencer key on. Start sequencer. This automatic sequencer has been preset to start instrumentation as well as fire the missile. and the flight safety officer has the means to destroy the missile in flight if anything goes wrong. By pressing this button, he can send an impulse which will blow off a wing. The launch director in the blockhouse has a similar button. All eyes, the cameras, radar, more cameras, more radar, all concentrated on one thing, the missile, our star. Tied to the ground by only one thing, the electrical umbilical. Now that's gone. She's on her own. All those weeks of work, all the tests and checks are finally going to pay off. Or not pay off.
T-minus 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, mark.
There she goes, completely under her own power, now that the boosters are gone. In spite of all our tests, this is a tense moment until we see that the guidance system is going to behave. If there is any malfunction, the guidance test engineer will detect it, and the ground control pilot will override it and control the missile from here. But everything is going well. Our star is behaving exactly as she should. At the rate she's traveling, she'll soon be approaching the first downrange station. Their telemetry signal voltage is getting stronger and stronger. These signals are being relayed by the submarine cable back to the telemetry building at the Cape. The telemetry supervisor is balancing the signal strength, and at the right second, will order the switch over to downrange receiver. There it is. Now the downrange station is the primary receiver. And pretty soon, there will be another switch to the next station as the missile speeds on her way at nearly the speed of sound. She's really traveling. The radar antennae are keeping up their ceaseless watch. And at all times, the flight safety officer must watch for the slightest deviation. And still she goes on, undeviating. She's over station 4 now. The telemetered information is flowing in and being funneled back to the Cape, now hundreds of miles away. Heading relentlessly for her target, on she flies, beautiful and deadly. Exciting as all this is, don't forget that it is to acquire the data being recorded here at the Cape that we launch these birds. And in a day or so, we shall have the complete picture. All our films and timing records pass through these highly complicated machines which reduce the photographic data to punched tapes. These tapes then go to the big brain, the flat computer, which makes the necessary mathematical calculations and records its answers in a matter of seconds on punched tapes. Now we almost have it. One more step. The flexowriters produce the data in tabulated form. Doesn't look like much, but the missile flight test report tells an engineer everything he has to know. We've followed just one missile, but there are many others under test at the center. There is, of course, Matador, now in full operational use. There is the BOMARC, ground-to-air interceptor missile. The Army's ballistic missile, Redstone. In the earlier research and development stage is the strategic aerodynamic Navajo and the new ballistic missile Atlas. But this is only the picture today. Tomorrow may bring some new, strange brainchild of the scientists, and we shall be vitally concerned with it. For progress is the watchword at the Air Force Missile Test Center.